Today we're going to talk a little bit about capacitors. Our number one replaced component is the run capacitor. So it's one of the things that we must check. I tell my students, you better check this capacitor on every single call you go to. Even if it's not the problem, you better know that this is not going to be the problem in the future. So it's very important that we check that. So a few things about that. There's two methods to check it. And that goes back to one of my rules is you want to check everything you can while the system's running, if it's running. And if the system's off, you want to check everything you can while it's off before you ever start it. So if that unit's off, I want them checking that capacitor before they power it up. And the reason being, we have a bad capacitor, they know it ahead of time. There's nothing like having that compressor try to start with a bad capacitor and trip on internal thermal overload. A lot of downtime, we can't have that. On the other hand, we have this system right here that's up and running, fully operational. I don't want to shut this unit down just to check that capacitor. So one of the problems we have with that, 5 minutes of equalization, waiting for it before we restart it. And then after I check it, power it back up, that's 15 minutes at least before I can do superheat and subcooling accurately. That's 20 minutes of downtime. We just can't have that. So this system's already running. I want to check everything I can while it's running, including that capacitor. So let's do a quick little check on how we can do it, and also it's more accurate. So what we're going to do is we'll get this little formula here. We want to get our start winding, amps. We're going to multiply that by 2,652. That's just a given. That number is going to be divided by the voltage across the capacitor. So over here, just drawing a capacitor out. We're going to take our meter, clamp it around the wire coming off the Herm for the compressor. We're also going to need the voltage across those 2 points right there. Put that into our formula, then we'll be good to go. So while this unit's operating, let's get those numbers. First off, here's the Herm terminal. The start winding going to the compressor. I'm pulling on this one 3.8 amps. Right over here, 3.8 amps. I'm going to multiply that by our factor of 3.8 times 2,652. And that gives us a number of 10077.6. Next, the voltage across the capacitor. From C to Herm, I'm getting 290 volts. Let's write that number down. 290 volts. First number is already in my calculator. I'm going to hit divide and then press 290. That gives me a number of 34.75 microfarads. That's how many microfarads this capacitor is working with. Now this capacitor is rated for 35 microfarads, plus or minus 5%. With 5%, I can be as high as 36.75 or as low as 32.25 and still be good. We are definitely good on that capacitor for the compressor. Let's check the fan motor though. We'll check the fan motor. Find the fan motor start winding. It's almost always brown. Coming off the fan terminal, we got 0.4. Right over here, 0.4. We'll throw that number in our formula. We got 0.4 times 2,652 equals 1060.8. Now we need the voltage across the capacitor. So between C and fan, 203 volts. So we're going to put 203 here. That number is already in my calculator. I'm going to hit divide, 203. That gives me a total result of 5.2 microfarads. The fan is rated for 5 microfarads. Maximum that fan can be is 5.25 or as low as 4.75 with a 5% variance. We are in good shape. We are right just within that variance, 5.2 microfarads. So this capacitor is in good shape, and I didn't have to shut it off. If I did have a problem with that capacitor and I wanted to double check it, or maybe my math's wrong, then I can take the time to shut this unit off. And really quickly, we'll do that. We're going to shut this unit off. We never want to take for granted that it actually shut off. We've seen way too many of these disconnects bypassed. Non-contact voltmeter, no voltage. Sorry, I'm old-fashioned. I still want to check it with my meter. I'm going to put it on volts. Line 1 to ground, 0 volts. Line 2 to ground, 0 volts. Line 1 to line 2, 0 volts. And just to be sure, from C, Herm, and fan, we're good. I got my 20,000 ohm 5 watt resistor. I'm going to put it between C and Herm. 1, 2, 3, 4, 5. Put it between C and fan. 1, 2, 3, 4, 5. I'm going to isolate. Pull these wires off real quick. Grab my meter. Set it for microfarads. Check between C and Herm. Let it charge. Let it charge. Let it charge. 34.85. And between C and fan, let it charge. Let it charge. 5.04. So we are in good shape. We can put our wires back on. Finish waiting our 5 minutes, power it back up, wait 15 minutes, then we can do our superheat and subcooling. But while we're on that topic, it's also very important when we mount these new capacitors, when at all possible, it's best to mount them upright. There's oil in here that's going to keep these cool. The cheaper capacitors use thinner oil. Sometimes you can even hear that oil shaking there. So that oil all the way down at the bottom keeps that capacitor cool. There's usually a small gap at the top, and that's just where your capacitor connects to the terminals. If you mount them upside down, you have a bit of your capacitor exposed, not getting that cooling effect. So when possible, it's not always possible, when possible you want to mount that capacitor upright. Now, the other thing you want to do is mount this capacitor metal to metal, metal to metal to metal. This capacitor is metal, so it's touching metal. If there's an issue where it shorts out, it will ground to the metal, ideally blow a breaker, pop a breaker, blow a fuse. Some kind of a safety issue will happen that saves our lives. So when it's mounted metal to metal, it's not an issue. We can use what we call a plumber strap with all the holes in it. Find a spot on here that already has holes started. Either way, make sure there's no copper behind it. Use the plumber strap, mount that new capacitor upright so there's not going to be an issue with it. And please, please take it out of the box and mount it. It's not that much harder. We do get paid for what we do. Maybe you have to charge the customer a little bit more for doing it that way, but it's just absolutely one of the worst things I can see is a capacitor left in the box sitting in that unit. Metal to metal to metal, upright when possible. It'll be a nice install. If you guys have any questions, please let me know. Thanks for watching.